Welcome to the lecture on calorific value. Before starting the calorific value, let us recall the important points of the earlier lecture. In the earlier lecture, we had discussed about the introduction of fuels. A fuel means nothing but any combustible material which contain carbon as the major constituent and which on combustion produces large amount of heat. So fuel is nothing but a combustible material. Which on combustion produces large amount of heat. The produced heat can be utilized for domestic or industrial purposes. Next we have discussed about the types of fuels or classification. So fuels are basically classified as natural fuels and synthetic fuels. These natural fuels can also be called as primary fuels, and synthetic fuels means secondary fuels. So later we have discussed about the various types of natural fuels and synthetic fuels. Next we have discussed about the differences between solid, liquid and gaseous fuels. After that we have discussed about the advantages and disadvantages of fossil fuels. Fossil fuels means nothing but the naturally occurring fuels which contain carbon as the major constituent. Later we have discussed about the characteristics of a good fuel. In that, the first characteristic is calorific value. So now we will discuss in detail about the calorific value. So calorific value means it is the total amount of heat liberated when a unit mass of fuel is burnt completely in air or oxygen. It is used to identify the efficiency of a fuel. The amount of heat liberated can be measured by the following units. Calorie. Calorie means it is the amount of heat required to raise the temperature of 1 gram of fuel by 1 degree centigrade. Kilocalorie. It represents the amount of heat required to raise the temperature of 1 kilogram of the fuel by 1 degree centigrade. British thermal unit. It is the amount of heat required to raise the temperature of 1 pound of water through 1 degree Fahrenheit. Next unit is centigrade heat unit. It is the amount of heat required to raise the temperature of 1 pound of water by 1 degree centigrade. Now we will see the relation between these heat units. So calorie means in general we will be showing as cal. This will be denoted like this in terms of kilocalorie. British thermal unit means we will denote like this. and this is the chemical heat unit relation. 1 kilocalorie is equal to 1000 calories is equal to 3.968 British thermal unit is equal to 2.2 chemical heat unit. One British thermal unit is equal to 252 calories is equal to 0.252 kilocalories. Next, types of calorific value. Higher or gross calorific value, that means it is the total amount of heat liberated when unit mass or unit volume of fuel has been burnt completely and the products of combustion are cooled to room temperature. Lower or net calorific value, it is the net heat produced when unit mass or unit volume of fuel has been burnt completely and the products of combustion are allowed to escape. So here gross calorific value is calculated when water in combustion products is in liquid form. So that's why we are showing they are cooled to room temperature. And this net calorific value, this is calculated when water in combustion products is in vapor form. So coming to solid or liquid fuels. For solid and liquid fuels, the units will be calorie per gram calorific value units or kilocalorie per kilogram or British thermal unit by LB. For gaseous fuels, they are expressed in terms of kilocalorie per meter cube or British thermal unit per feet cube. Next, calculation of low calorific value. Low calorific value is equal to high calorific value minus latent heat of water vapor formed. Hydrogen in the fuel reacts with oxygen to give water as H2 plus half O2 gives rise to H2O. That means 2 parts of hydrogen, 16 parts of oxygen will react to form 18 parts of water. That means 1 part of hydrogen is equal to 8 parts of oxygen is equal to 9 parts of water. The meaning of this one is 1 part by weight of hydrogen produces 9 parts by weight of water. That's why LCV is equal to HCV minus mass of hydrogen into 9 into latent heat of steam. Latent heat of steam value is 587 calorie per gram or 587 kilocalorie per kilogram. From this, LCV is equal to HCV minus 9 into hydrogen by 100 into 587. So finally the formula will be LCV is equal to HCV minus 0.09 into hydrogen into 587, which is nothing but the latent heat of steam. Here hydrogen is equal to percentage of hydrogen in the fuel. Next, theoretical calculation of calorific value. So theoretically how we will calculate means by approximating the calculated by noting the amount of constituents and heat of reaction into consideration, which is defined as the amount of heat produced when 1 gram of the reactants is burnt in presence of oxygen. So here what we should take into consideration? Amount of constituents and heat of reaction. So in general the constituents of any fuel will be carbon, hydrogen, oxygen, sulfur. These are the common constituents existing in a fuel. If we take carbon present in the fuel will undergo combustion by reacting with oxygen and gives rise to CO2. So during this process 96,960 calories of heat will be liberated. So here 12 grams of carbon combines with 32 grams of oxygen, producing 44 grams of carbon dioxide, liberating 96,960 calories of heat. That means 12 grams of carbon liberates 96,960 calories of heat. Then heat liberated by 1 gram of carbon will be equal to 96,960 by 12 is equal to 8,080 calories. So 1 gram of carbon gives 8,080 calories of heat. Next one is hydrogen. If we take hydrogen, H2 plus half O2 gives rise to H2O, and during this process 69,000 calories of heat will be liberated. So 2 grams of hydrogen, 16 grams of oxygen, 18 grams of water, and the heat liberated is 69,000 calories. So 2 grams of hydrogen liberates 69,000 calories of heat. Therefore, heat produced or liberated by 1 gram of hydrogen will be equal to 69,000 by 2 is equal to 34,500 calories of heat. So 1 gram of hydrogen liberates 34,500 calories of heat. Next one is sulfur. So S plus O2 gives rise to SO2, sulfur dioxide, plus 71,680 calories of heat will be liberated. So sulfur 32 grams, oxygen 32 grams, and sulfur dioxide 64 grams, and the heat liberated is 71,680 calories. So 32 grams of sulfur liberates 71,680 calories of heat. Then, therefore, heat liberated by 1 gram of sulfur is equal to 71,680 by 32 is equal to 2,240 calories. That means 1 gram of sulfur produces 2,240 calories of heat. By using this, the formula for calculating the calorific value is HCV is equal to 1 by 100 into 8,080 percentage of carbon plus 34,500 hydrogen minus oxygen by 8, 2,240% sulfur, kilocalorie per kilogram. This formula is called as Joule formula. So here, now I will explain this. That means amount of oxygen. If oxygen is present in a fuel, it will be existing in combination with hydrogen as H2O. Thereby, it reduces the weight of hydrogen by oxygen by 8. That means amount of oxygen is equal to amount of hydrogen minus fixed hydrogen. That means H minus oxygen by 8. Already I showed you earlier. 8 parts by weight of oxygen combined with 1 part by weight of hydrogen to form H2O. 9 parts by weight. So that's why while calculating the amount of oxygen in the calorific value formula, we have to subtract this from the amount of hydrogen. Thank you. In the next video, we will practice few problems on this calorific value determination. Thank you.